Good morning, good morning. I appreciate y'all coming in today. Let's go ahead and talk about more of these exponent rules that we're going to be working on today, okay? First and foremost, I need to be able to make sure that you have your notes from last class. You're going to need them for when we start working on the worksheet. The ones that have the exponents with the zero exponent, the ones that have the exponents where you're multiplying same bases, when you're adding same bases, and when you're dividing and all that kind of stuff. So if you need to pause the video to get it, please do. Just know that we are going to be using some of that when it comes to these activities we're going to be doing and some of these assignments and some of these questions. So when it comes to more of these exponent rules, what we're looking at is going to be these negative exponents, and this is by far the most commonly weird thing that you're going to see when it comes to exponents, just because it is a rule that is easy to overlook. Whenever you have an exponent that is negative, you're going to pretend that what you're working on is a fraction, and that you're going to switch sides of the fraction from bottom to top or top to bottom for any of the bases that have a negative exponent. So like in the example that I've given you on the first part here, look at where this 2x to the negative 2 is. The negative 2 is being applied directly to the x. So because of that, you are going to be switching the x with the exponent 2 from the top of a fraction, even if it doesn't look like there is one, to the bottom. Remember how we have fractions and I go rise over run, 2 over 1 and all that kind of stuff? Because every number is over 1 automatically, then you're going to be able to make it into a fraction. And you can put that x to the 2 underneath that fraction. Since the 2 by itself is not got the exponent being applied to it, the 2 is separate, it goes on top of this fraction, okay? Next thing I want to talk about is when you have a fraction that the negative exponent is on the bottom, it goes from the bottom of the fraction to the top. Like if you look really closely, this x to the negative 3 switched to the top up here because of that negative. The negative 7 that's on top up here, that y negative 7 comes down to the bottom. The 2 itself stays the same. That's going to be how these negative exponents work, okay? When you have exponents to exponents, you're going to multiply the numbers that are exponents. And you're going to apply that exponent to anything else that is in parentheses, like on this first example. Right now it's being to the 4th. That to the 4th gets multiplied by this 2 right here. That's where this 8 comes from. But not only that, but it goes to this 2 at the front as well. That 2x squared is inside parentheses. So that means everything inside the parentheses gets that exponent applied to it. That's why you see 2 raised to the 4. X raised to the, 2 times 4 to get the 8. Now 2 to the 4 can actually be calculated in the calculators. It is 2 times 2 times 2 times 2. 2 being multiplied, a total of 4 2's being multiplied together, and that's where that 16 came from. You could actually type that into the calculator if you wanted to, using that little caret on the left side. It looks like that symbol. Whatever number you put in, press that number and it'll let you raise it to whatever exponent you need to, and that will let you figure out what number that is. Now, if you look at the right one, the one that has a 3x to the 3rd, that to the 3rd is only being applied to the x. That means that the 3 doesn't have that being applied to it. When you go to multiply that with the negative 2, the negative 2 gets applied to the 3 and to this 3. That 3 automatically has an invisible 1 at the top of it. There's automatically an exponent of 1. So when you go to multiply, negative 2 times 1 gives us this negative 2 here. Negative 2 times 3 gives us this negative 6 here. And that negative 3 squared, if you think really carefully about it, it would be 1 over 3 squared. That's the same as saying 1 times 3 times 3, and 3 times 3 is 9. That's where the 1 over 9 kind of came from. That negative 6 says also that you have that 6 and the x going to the bottom of the fraction. That's where that is right there, okay? That's what that is. What I'm looking for now is for us to use these as we start solving on the couple of examples that we have on the back, or the bottom of this page, I should say. So let's look at, first off, the exponents and fractions. When you have exponents on fractions and when you have exponents like this, the exponent gets applied to both the top and the bottom equally, okay? So that squared tells us that we get 4 squared. And you can get 4 squared and 5 squared by applying that squared to the 4 on top and the 5 on the bottom. 4 times 4 is 16, 5 times 5 is 25. That's where those numbers come from. Then I also multiply our exponents, just like we were multiplying them on the outside. 2 raised to the 2, or excuse me, 2 times 2 is 4. And that since that exponent on the outside gets applied, then we multiply like we did on the previous slide. That's where this 4 comes from, 2 times 2. And then the 2 times this exponent 3 down here as well is going to be where that shows up. The last thing I want to talk about is on some of our work that we have going on here at the bottom. Let's go ahead and talk about how to solve some of these. I want you to look at this -4 down here. That -4 tells us that we're going to switch sides from bottom to top. So you get y times y to the 4 without any fraction, because if that y to the -4 goes out of the bottom, then there's nothing left in the denominator there. Y times y4 is y1 times y4. What that happens is we take our y's, we multiply them, we get y to the 5th power. Just like yesterday we had the multiplication thing, we just add those exponents. 1 plus 4 is 5. That's where this answer comes from. On this fraction on the right side, we pay a little bit more careful attention because I see that -4 right here. When that -4 happens, it swings from top to bottom. And when I get that, I get 4 over 6 b to the 3rd times b to the 4. I can add the 3 and the 4 together to get b to the 7 underneath. 4 to the 6 is going to be reducible though. 4 over 6 happens to be 2/3. So that's actually what I'm going to be looking at here, is once I kick the b out of the top, all that's left is the 2/3 from reducing these. The next thing I'm looking at on this right one is these r's. R to the -2 goes to the top. 2 plus 2 is 4. I get r to the 4. I can't even write right now. I apologize very much. It's supposed to be r to the 4. I take that -3 and I swing it from top to bottom. I have 3 plus 3, which is 6. And that is going to be s to the 6. On the bottom. 9 over 6 reduces as well. That 9 over 6 is going to be 3 over 2. So my fraction here, 3r to the 4 over 2 s raised to the 6 would be the answer on this question. I've still got 3 more to do. I'm going to keep this set of steps up here so we can follow them. Handle the coefficients first. 9 to the 2 doesn't even reduce. I know I'm going to have a 9 over 2 as we start solving this. We can kick the y from the top to the bottom by converting that -3 exponent to +3. So when I look at that y to the 3 and another y to the 1, when I add those together, I get y to the 4. Then the w to the -2 and the -5, you can cancel those two. Okay, when you start canceling out these -2's, you get w to the -3 on top. If you think really carefully about that w to the -3, if that's on top, to switch it, you can switch it to the +3 and put it on bottom. So w to the 3 on the bottom, that's going to be our fraction. Where it gets a little bit crazier is when we start applying this 3 on the outside, okay? You have to be able to cube all of these numbers. You literally are going to go 9 to the 3, 6 times 3, because when you're having this exponent applied here, you're going to multiply those exponents together, over 2 to the 3, c to the 2 times 3, and z to the 4 times 3. Literally, that 3 gets applied into everything first, and then we can take care of those exponents. 9 to the 3, if you plug that into the calculator, you're going to get, what is it, 81? No, it's not 81. 9 times 9 is 81. Times 9 again is going to be 9, and then 72. So you're going to get 729 over 2 to the 3 is 8. C to the 6 times 3 is 18. C to the 6. I can cancel those out. I'm going to end up with c to the 12 on top. And then, yes, z to the 12 on bottom. All right, let's go ahead and do the last one. I can still take care of this. Something that I've done before that I know works a little bit better so you don't have to do a lot of canceling is we could actually cancel the stuff before we apply the exponent to it. So like, for example, 6 over 9 reduces to 2 over 3. N to the 4 and n to the 5 leaves just one n on the bottom. B to the 2 and b to the 3 leaves just one b on the bottom. And so when I square all of that, 2 times 2, because 2 squared is 2 times 2, 4. 3 times 3, because 3 squared is 9. Over n squared and b squared. That is going to be the answer for this one. I kind of like the idea of reducing it first and trying to simplify it before you apply the exponent to it. If you do apply the exponent through the parentheses before you reduce it, not a big deal. It'll just make a little bit of extra work for when you're done, but it is absolutely still doable. I'm going to have you go ahead and begin on your worksheet just now. You guys got this, all right?